AP Calculus, this was your quiz for today. The solutions are on your class page, but I want to talk about each of these. Question 1, you needed to know the definitions. And these are things that you have to just memorize. You could draw the picture if you like, but you need to remember that if you're looking for the derivative at a point C, then the difference quotient is x minus c and f of x minus f of c. If you're looking for the derivative at any point x, it's the limit where h goes to 0, and there's an h on the bottom, f of x plus h minus f of x. Just memorize those two exactly, be able to reproduce those whenever you need. Picture-wise, if we can just think of a graph of a function f, and we have a point, this is c and f of c, so that's the ordered pair, c comma f of c, and another nearby point, x now is going to be a variable. This is x comma f of x, and we can find the slope of a secant line very easily by just doing rise over run. So take these two and subtract the y coordinates, that's this, subtract the x coordinates, that's this. To get the slope of the tangent line, which is what we really want, you just make x go to c. So it's a limiting process as x goes to c, and that's what this says. Okay. For the other one, the variable now is h. Again, very similar picture. You have a function f. You have a point now that's arbitrary. X represents any x value. This is f of x. And you pick a nearby point, x plus c, or x plus h, with this horizontal increment being h. And so this ordered pair is x plus h and f of x plus h, whatever the function might be. And again, you can find the slope of the secant line very easily by just doing rise over run. Use these coordinates. And now if you look at this up here, it's not quite h. Technically, it would be x plus h. That's an x coordinate, and that's an x coordinate. So here's your two x coordinates. This is x and f of x. But notice that x plus h, take away x, is h all the time. It will always be h. That's the run, right? And then the rise, this amount here, is this y coordinate, take away this y coordinate. Okay? Just memorize the two limits and be able to use them in problems. So in problem 2, we were asked to use the first definition to find the slope of the tangent line. So f of x is equal to x squared minus 9. This is your c and your f of c. And so we can just write f prime of 2 is a limit as x goes to 2. We have x minus 2. We have the function x squared minus 9. Take away the y coordinate, which was negative 5. Okay, so we work this limit out. This is the limit as x goes to 2. Notice up top we have x squared minus 4, right, because this is minus 9 plus 5. X squared minus 4, this is x minus 2, obviously a difference of squares, factors very quickly. Now, the fact that this was a homework problem, for heaven's sakes, you should have been able to do this in very, very little time. X plus 2, x minus 2, x minus 2, and then cancel, and then substitute 2 plus 2 is 4, and that's the answer. Okay, so the slope of the tangent line is 4. Problem number 3, you had to use the second definition. So now we're doing f prime of x is a limit as h goes to 0. Again, if you have the definition, this is not hard to do. This is h. This is always going to be your function back here, x plus 4. Now remember up top, or in here, you are going to be putting f of x plus h. And so that may require a little bit of work. We have to understand how the function f works. So off to the side, if you have to, let's see, f of x for this problem is the square root of x plus 4. If I said, what's f of 5, you'd use that's the square root of 5 plus 4, which is square root of 9, which is 3. If I said, what's f of 10, you'd go, that's the square root of 10 plus 4, which doesn't really clean up, square root of 14. If I, for some reason, wanted f of pi, that would be the square root of pi plus 4, you can see how this function works. Whatever is there fits right in there. So if we wanted the f of stuff for this function, it's the square root of stuff plus 4. What we want is f of x plus h, so that's the square root of x plus h plus 4, and that's what goes in our difference quotient. Again, hopefully you don't have to do that for every problem. This is the square root of x plus h plus 4, and that's the limit we have to work. Okay. Now, if you notice, if you plug h is equal to 0 in here and here, you get the square root of x plus 4, take away the square root of x plus 4, which is 0, and over 0, 0 over 0 is not the answer. We have to do something with this limit so that we can actually work it out. And whenever you see these radicals, the conjugate idea comes into play very quickly. So this is the limit that we're trying to deal with. Take away the square root of x plus 4 all over h, and I'll multiply this by the number 1 using the conjugate. So square root of x plus h plus 4 plus the square root of x plus 4, right? Conjugates, you just change the negative to a positive. So square root of x plus h plus 4, and then plus the square root of x plus 4. The next step is a little, you got to be careful, because when you do this multiplication, let's see, in the first multiplication, when you do this radical times that radical, you simply get x plus h plus 4. In the second multiplication, you've got a negative radical, and you're multiplying it times a positive radical. That gives you a negative x plus 4. And you do need those parentheses there. Okay, on the bottom, I'm not going to multiply this out. I'm just going to leave the h from here and then indicate the multiplication as the square root of x plus h plus 4 plus the square root of x plus 4. Okay. Hopefully doing this, everything cleans up. We get a nice answer. So limit as h goes to 0. Up top, if you look at it carefully, the x's go away and the 4's go away because you have to distribute that negative sign. So you simply get an h. On the bottom, you have the h. They're going to cancel. You have the square root of x plus h plus 4 and the square root of x plus 4. Okay, so these guys go out, just leaving a 1 up top. So now we have the limit as h goes to 0. We have 1 over the square root of x plus h plus 4 plus the square root of x plus 4. Okay, and now we substitute. Where there's an h, we just put it 0 right there. And when you do that, you get 1 over the square root of x plus 4 and another square root of x plus 4. So stuff plus stuff is 2 stuffs, so 1 over 2 of those things, square root of x plus 4. That's the answer. Okay, the last problem was much quicker. It said, first of all, we're going to be using this. We need to plug in the point, so the 2 is going to go there. The 8 is going to go there. That's our x1 and our y1. All we have to do is calculate the slope, and the slope is pretty easy. We've got y is equal to f of x, which is equal to x cubed. If you remembered the derivative using the power rule from our discussion on Tuesday, you could have just written this down as 3x squared. Okay, but if not, then, and by the way, this is the derivative everywhere. We need the derivative at 2. So what we really want is f prime of 2, which would be 3 times 2 squared, which is 12. That's the number that's going to go right there. And once we have that, we're done with the problem. But let's pretend we didn't know the power rule or we didn't remember it. So what we're looking for is the derivative at 2, and that's the limit as x goes to 2. This is x minus 2. This is x cubed minus 8. Yeah, we do have to factor. You will see this factoring problem again and again and again. If you don't know how to factor a sum or difference of cubes, for heaven's sakes, learn it, because you're going to go down the tubes if you don't. Okay, so factored, now you can cancel, and then you can substitute. And so we're substituting 2 right into there and there. And so this works out to be 4 plus 4 plus 4, which is 12. Okay, so the answer, the direction said leave it in point slope form. So y minus 8 equals 12 times x minus 2. Done. Okay, that quiz should not have taken more than 5 minutes, especially since you did the problems for homework. I gave you class time to ask questions about those problems. Expect another quiz on Monday on problems similar to this. Okay, I'm going to stop the video here, but I have to do another video on what we were supposed to cover today, which is the power rule. So please, take this one to heart. 10 minutes of your time. Sorry for making it boring. We are going to do another 10-minute video. This is on material from section 2.2. Follow along in your book if you have to. Thank you very much.